all the grade 12s. I say welcome back to it. It's Maths Masterclass with Leo. We are still doing our winter sessions, and today our focus area is on series and sequences. We did introduce number pattern. Today we're doing series and we're doing some of the series, right? So with some of the series, we need to know for linear pattern, right? Or arithmetic pattern or arithmetic series, right? So we already talked about the formulas. We already showed you the formulas, which the first formula we said is going to be your Sn. This is equals to your n divided by 2 into your a plus your l, where your Sn represents the sum of the nth terms. We said this represents the sum of the nth terms, and your n represents a position where your a is your first term and your l is your last term, right? And then the second formula that we talked about, we said the second formula is going to be Sn. This is equals to n over 2 into 2a plus into n subtract 1 close bracket d. Right? We said this formula, we use it whenever we're given the last term. Whenever we're told that the last term is equal to this, then we can use this formula. But if we're not told, we can use this one. Because this, you just need the, you need to be told, determine the sum of the 10th terms. Sum of the 10th terms, meaning the value of n is 10. And then the value of a, you'll be given the pattern or the series. And then you can just calculate your value of d, which is your common difference, right? Without any further complaints, let's get an example, try to deal with it using these formulas. And the first formula that we have, the first question or example that we have is when we're given 1 plus 3 plus 5 plus 7 plus, right? And then the first question, they want you to determine the sum of the 10th terms. Determine the sum of the 10th of the first 10 terms, right? So they want you to determine the sum of the first 10 terms in this case. So determining the sum of the first 10 terms, you can see that this, it means it represents the value of n, right? Now we can't use this formula because we are not given the last term. If we were given the last term, they were going to say 1, 3, 5 plus 7 and then plus, and then they say plus maybe 21 here. That is how they will represent it in terms of the last term. 21 is your last term, that's where you can substitute it here. So in this case, we're not given this example, we're not given the last term, so we're just going to use this formula. So we have 1 plus 3 plus 5 plus 7. We can now calculate the common difference, d2 minus d1, d3 minus d2, and t4 minus t. D is equal to t2 minus t1, which in this case will be 3 minus 1. And then d is also t3 minus t2, which this is going to be 5 minus 3. Both of this, they are giving me 2. So therefore, this means this is an arithmetic sequence. This is an arithmetic sequence. After doing that, this will be 2, this will be 2, and that will be 2. After doing that, I can now come to this formula and substitute. Sn is equals to n divided by 2 into 2a plus into n minus 1 close bracket d. Where now S10 is equals to 10 divided by 2 into 2 into the value of a is represented by 1, which is your first term. So this is 1 plus into the value of n is represented by 10 minus 1, then 2. This gives me 5 into 2 plus 9. This is 18. And this gives me 5 into 20, which the solution is 100, right? The solution for that is equals to 100. That is how you calculate the sum of the first 10 terms, right? That is how you calculate the sum of the first 10 terms. Sometimes they'll just give you the sum of the first nth terms, or the sum of the n terms, and then they need you to calculate what? The value of n. For example, let's go to the next page. For example, they say determine, skip this, they say determine the value of n. So in this case, they just told you what to determine, which the sum of the first n terms is 2 to 5. So in this case, you are given Sn, which is equals to 2 to 5. We're still using the very same pattern. We know the value of a is equals to 1. We don't know the value of n. We know the value of d is equals to 2, right? So we can now say from this, Sn is equals to n divided by 2 into 2a plus into n minus 1 close bracket d, right? And then n is represented by, we don't know, but we know Sn. This is 2 to 5, right? Then n divided by 2 into 2. The value of a is 1 from the previous pattern that was saying 1 plus 3 plus 5 plus 7 plus into n, we don't know it, minus 1 close bracket, d it is 2, right? Then 2 to 5 is equals to n over 2 into 2 plus 2n minus 2, right? And then I can now cross multiply. Then 2 to 5 multiplied by 2, this is equals to n into 2n, negative 2 will cancel into 2n. And then 450 is equals to 2n squared divided by 2, divided by 2. This and that they cancel. Then I have n squared is equals to 2 to 5. Then square root of 2 to 5, it is plus minus 15, but n cannot be negative 15, therefore n is equals to positive 15, right? Therefore n is equals to positive 15. The reason for that, n cannot be negative, n cannot be 0, n cannot be a decimal, n cannot be a fraction. N will always be a whole number. That is it from some of the series for arithmetic. Let's check another question if we have any. Yes, we have another question or another example that we can do. The second question, we're given negative 3, negative 2, negative 1, plus 0, plus 1, plus 2, right? And then this is our pattern. Determine the value of n for which the sum of the first n terms, okay, in this case they are saying determine the value of n, for which the sum of the first n terms, is 1075. So now we can see that we can't use the first formula. We can't use Sn is equals to n over 2 into a plus l. Why? We don't have the last term. But we can use Sn is equals to n over 2 into 2a plus into n minus 1 close bracket d. We can use that formula. Then now we are given Sn, which is 1075. We know what is the value of a, negative 3. We don't know the value of n, but we can get the value of d by saying d is equals to t2 minus t1 where t2 in this case is negative 3, negative of negative, t2 is negative 2, negative of negative 3, then this gives us negative 2 plus 3, which is 1, right? We can also try and check if ever this is an arithmetic indeed. So t3 minus t2, where t3 is represented by minus 1, minus into minus 2. This is minus 1 plus 2. This is equals to 2, right? Nope, this is equals to 1, not 2, sorry about that. This is 1. Then we know that the difference is 1 now. From there, we can substitute. Sn is 1075. This is equals to n, we don't know, divided by 2 into 2. The value of a is negative 3, plus into n, we don't know, minus 1, close bracket, and 1. Then this will be 1075 multiplied by 2. This is 1075 multiplied 2. This is equals to n into, this is a negative 6 plus n minus 1 plus n minus 1. And then 1075 is going to be 2150. This is equals to n into negative 7 plus n, right? And then when we simplify it, it's going to be negative 7n plus n squared. This is equals to 2150, and then n squared minus 7n minus 2150, this is equals to 0, right? And then we can now try to factorize this. Let me see on my calculator. If I try to factorize this, this will be n 50 and 43. This is positive, that is negative. This is equals to 0, right? You can also use your quadratic equation for this. If you don't know how to factorize, try to use quadratic equation. So you can see that here, if I get some space here on top, you can see that n is equals to 50. What's happening? What's happening? N is equals to 50. N is negative 43, where n cannot be negative 43, therefore n is equals to 50. That is my solution, right? That is my solution for this question. I hope you understand. Don't forget the reasons why n cannot be negative. Don't forget why n is equals to 50, because n cannot be negative, n cannot be a fraction, n cannot be in decimals, n cannot be 0, right? Those are the 3 or 4 things that you need to know, right? Now, let's check out geometric series. For geometric series, you have a few questions. You need to know what is your Sn is equals to a into r to the power n minus 1, right, divide by r minus 1, or Sn, this is equals to a into 1 minus r to the power n, divide by 1 minus r. Lastly, sum of infinity, this is equals to a over 1 minus r, right? Those are the formulas that you need to know, and this goes with a condition when you can use this when your value of r is in between negative 1 and 1, meaning your value of r, it converge, right? Then now, let's get a question. An example, 2 plus 6 plus 8 plus 54, that is 18, not 8. And then now, Determine the sum of the first 10 terms. Determine the sum of the first 10 terms. Right? So in this case, the sum of the first 10 terms, we're looking for Sn. We don't know what is Sn. We know what is the value of A, represented by 2. We don't know what is the value of R, but we can calculate it. We know what is the value of N. They said 10. We can calculate the value of R by saying R is equal to T2 divided by T1, where T2 is given as 6 divided by 2. Then this gives you 3. Again, R is equal to T3 divided by T2. This is 18 over 6, which this is 3. Right? So always try to check 2 of these. Calculate 2 values of R to check if ever that is a geometric sequence or not. If it doesn't give you the same answers, recheck again. Then if it doesn't give you, you can see that it doesn't give you the same answer. That is not a geometric sequence. Therefore, the value of R in this case is 3. Then we can now use either this formula or this formula. Both of them, they will give you the same solution. Let's try one. We'll try both of them. We'll try both of them. You will see. So in this case, S10, this is equals to A is represented by 2 into R is represented by 3 to the power 10 minus 1 divided by 3 minus 1. Get my calculator, see what's happening. Okay, this is 2 into 3 to the power 10 minus 1, close bracket, then 3 minus 1. See, I'm getting 5904. 59048. Let's check another one. Let's check S10 is equals to 2 into 1 minus 3 to the power 10 divided by 1 minus 3. This should give us this very same solution. Let's check. Let's recheck this. This is 1 minus, then 1 minus. Exactly the same solution. 59048. 59048. See, exactly the same solution as we got. So now, let's get to the next question. Let's get to the next question, which is the last question for the day. Now, the last question says determine the value of n. The value of n for which the sum of the first n terms is 242, right? So in this case, I'm looking for the value of n. I know what is Sn. I'm still using the very same pattern or series. Sn is given as 242, right? And then A, it is 2. R, we don't know. Oh, we know it's 3. N, we don't know. Right? We don't know what is the value of n. We know Sn, we know A, we know R. We don't know the value of n. We're looking for the value of n. So we know the formula that says Sn is equals to A into R to the power n minus 1 close bracket divided by R minus 1. Right? We know this guy. We substitute. 2, 4, 2. This is equals to 2 into R. R is given as 3 to the power n. Because we don't know what is the value of n. 3 to the power n minus 1, close bracket, then divide by 3 minus 1. Then when I cross multiply, this will give me 242 multiply 2. This is equals to 2 into 3 to the power n minus 1 divided by 2 divide by 2, that 2 is out again, I'm still left with 2, 4, 2 is equals to 3 to the power n minus 1. This one to the other side, I'm going to have 2, 4, 2 plus 1. This is equals to 3 to the power n. And then 243 is equals to 3 to the power n. Let's see if we can get factors. 2, 4, 3 is equals to shift fact. This is 3 to the power 5. So 3 to the power 5 is equals to 3 to the power n. Bases are the same, we leave them out. 5 is equals to n. Therefore, the value of n is equals to 5. The value of n is represented as 5. Don't forget to like, subscribe, and share the content with your friends. See you in the next video. Tango means thank you. Tango.